Hello, boys and girls. Welcome to Mrs. Bandu's Math Movies. This is Lesson 7.4 for Algebra, Applications of Linear Systems. So basically, we're going to write systems of linear equations, and we'll be using all three of our methods that we have previously studied for solving. We can use graphing. We'll use graphing for systems that are easily graphed. If the point of intersection does not have integers for coordinates, find the exact solution by using one of the methods below or by using a graphing calculator. Substitution, when one variable has a coefficient of 1 or -1. And elimination for solving basically any system. Okay? All right, so let's get right to it. It says the chemist has one solution that is 50% acid. She has another solution that is 25% acid. How many liters of each type of acid solution should she combine to get 10 liters of a 40% acid solution? So we have a lot of numbers floating around here, and so let's look at how would we put this together. So first of all, we're going to let A be the volume of the 50% solution and B the volume of the 25% solution. Okay, so A plus B, however much of each one, whatever you use in the end, has to add up to 10 because we want a total of 10 liters. Okay, so then 50% A, 50% solution of A, so we can do 0.5 or 0.50, and 0.25 times B to give us the 0.4 or 0.40 times 10. Okay, so 50%, some amount of the 50% solution plus some amount of the 25% solution give us 10 liters of a 40% solution. So it kind of pieces together like that. Okay. Choose one of the equations and solve for a variable. So we have A plus B equals 10. Let's go ahead and solve for A. So we'll subtract B. So A equals 10 minus B. So to find B, we're going to go to our other equation. So 0.5A plus 0.25B equals 0.4 times 10. Okay, that's just that original, the second equation that we have. Let me scoot up here so I don't lose the paper here. Okay, so now let's go ahead and multiply. So we are going to go 0.5 times 10 minus B, quantity 10 minus B, plus 0.25B equals 4/10 times 10. So we're substituting in the expression 10 minus B for A, and want to use parentheses and the distributive property. So half of 10 is 5, and then minus 1/2 B or 0.5B plus 0.25B equals 0.4 times 10. So this gives me 0.5 minus 0.25B equals 4. Okay, I will then subtract 5 from each side. And negative 0.25B equals -1. So B is 4. So again, I've subtracted 5 from each side and then divided each side by negative 0.25. So B is 4. So to find A, we're going to substitute in 4 for B in either equation. Okay, again, I generally try to substitute it back into the easier one because I don't always have to make things hard, okay? So we're going to use A plus B equals 10. So A plus 4 equals 10. Subtract 4 from each side, so A is 6. To make 10 liters of 40% acid solution, you need 6 liters of the 50% solution and 4 liters of the 25% solution. Okay, so that's how that pieces together. So again, your two equations here need to talk about the volume of the solution, the 10 liters, and then the 10 liters at the strength that you wanted to figure out the amount of each type acid. Okay. Let's look at our next example, finding a break-even point. Now, a break-even point is basically when expenses equal revenues. Okay, so you haven't made any money yet, but the point at which you start just before or when you start making money is when you break even. Suppose you have a typing service. You buy a personal computer for $1,750 on which to do your typing. You charge $5.50 per page for typing. Expenses are 50 cents per page for ink, paper, electricity, and other expenses. How many pages must you type to break even? Okay, so let P equal the number of pages and D equal the amount of dollars of expenses or income. Because again, break even means expenses are going to equal income. All right, so expenses are per page expenses plus the computer page purchase. So the expenses, D, is equal to 50 cents times P, the number of pages, plus $1,750. Okay, income is also D, and this is $5.50 times P, or the number of pages. So this is what it's going to cost you. This is how much money you're going to bring in. So income and expenses, in this case, because we're breaking even, they can be the same variable. Okay. Choose a method to solve this system. Use substitution, since it's easy to substitute for D with these equations, and it is, because either one of them, D equals something. Okay, so we're going to start out with D equals 0.5P plus 1,750. So what we'll do then is substitute in 5.5P in this first equation for D. I'm going to substitute that. Okay, so when I simplify by subtracting 0.5P from each side, that's going to give me 5P equals 1,750. So I subtracted 0.5P. And then I'm going to divide 1,750 by 5. So P equals 350. So to break even, you must type 350 pages. Okay, so the two we have to focus on here are getting a certain amount of a certain strength solution and then break-even point. And we also have another one. Oh, it's so fun. All right, finding speed. Okay, suppose it takes you 6.8 hours to fly 2,800 miles from Miami, Florida, to Seattle, Washington. At the same time, a friend flies from Seattle to Miami. His plane travels with the same average airspeed, but his flight only takes 5.6 hours. Find the average airspeed of the plane and find the average wind speed. Okay, so wind speed is what is the difference here. Okay, so first of all, we're going to let capital A equal the airspeed and capital W equal the wind speed. Okay, relate with the tailwind. So rate times time, airspeed plus wind speed is the rate, and you're going to multiply it by the time equals distance. So we're going to, from here we can write airspeed plus wind speed. Now the tailwind means that the wind is going to push you, so your speed or your rate is actually going to, your actual rate will actually increase, not necessarily the airspeed of the plane, but the wind speed is going to make it travel faster. Times the time of 5.6 hours is 2,800, which is your distance. Okay, so this would be Seattle to Miami, if that's helpful to you. And then Miami to Seattle. You have a headwind. Now, when you have a headwind, it slows you down. Just like when you're running into the wind, you can sort of feel the drag, and it does slow you down just a little bit. So airspeed minus wind speed will give you the actual speed at which you are traveling, times the time of 6.8 hours equals the distance of 2,800 miles. Okay, solve by elimination. First divide to get the variables on the left side of each equation with coefficients of 1 or -1. Okay, so in this case, we're going to divide each side. The first equation, we're going to divide each side by 5.6. And if you have a calculator out, that's fine. You're going to take the quantity A plus W times 5.6 divided by 5.6 and 2,800 divided by 5.6, which is 500. I'm going to double check that. 2,800. Oops. 2,800 divided by 5.6 is 500 exactly. Okay? All right, the next one. In this case, we're going to divide each side by 6.8. And that's going to be 2,800 divided by 6.8. And that gives me 412 to the nearest whole number, which is fine. That's going to be good enough. Okay, so now my equations have been simplified a little bit. We will add the equations because we have a positive and a negative, so, or a plus and a minus, so we can add. So A plus A is 2A equals 912. Okay, to solve for A, we'll divide 912 and A, 2A by 2, and that gives us A equals 456. So the airspeed is 456. Solve for W using either of the original equations. So we'll go with A plus W equals 500. So that's 456 plus W equals 500. So we're substituting in 456 for A, and you're going to have to subtract that from each side, and you get 44. So the average airspeed of the planes is 456 miles per hour. The average wind speed is 44 miles per hour. Now, it doesn't mean that that's exactly the way it is, but that's the average between the two. Again, the difference that it takes in time is the airspeed when it's a headwind is slowing you down because it's blowing into your head or your face, all right? And your tailwind is at your back, so it actually pushes you along and increases your speed slightly. Okay. Okay. Also here, you could go back, to me, the original equations are way back over here. You could substitute it in here as well, as long as you carefully eliminated when you eliminate it over here. So either way. Alrighty. So again, you have another example. And that should do it for 7-4. Get these done, bring in questions, and I'll see you very soon. Bye.